Unit 0 Notes, Math 1340, page number 2. In the following expressions, we would like to simplify each of these expressions. This is a continuation of question number 2 from the previous page. So again, we're going to use the rules that we learned about. The first rule that we're going to use here is the power of quotient rule. The power of quotient, we have a quotient, and notice how inside of the quotient we have a product, actually 5 times c. So here's how we're going to simplify this expression. So first we're going to distribute the 2 over the numerator and the denominator. So we're going to have 5c all squared over d squared all squared. Now I'm going to use the power of a product rule in the numerator, power of a product rule in the numerator, and then the power rule in the denominator. So I will distribute the 2 over the 5 and c, so we will get 5 squared times c squared over d squared squared. We're going to multiply, so d2 times 2. So now we're going to write the final answer here. This is 25 c squared, 5 squared is 25, over d to the 4th power. For e, notice how we have a rational exponent here. So we're going to use the last rule, which is rational exponent rule. So this one is going to be, we can either distribute the 1/2 first, or we can basically change that into a radical immediately. So this is going to be the index of the radical, and this is going to be the power or the exponent of the radicand. So here is the square root. Remember, sometimes, I just wrote the 2 for clarification. We usually do not write the 2 in a square root, and then xy, this is raised to the 1st power. Again, this is just for clarification, which is going to be square root of xy, or you can split it further. You can say this is square root of x times square root of y. There is no benefit of splitting the radical here, so we're going to keep it as ones. Last one, d, you have k to the 9th raised to the 5th power, k to the 3rd raised to the 2nd power. This is the power rule applied twice, so we're going to apply the power rule here and the power rule here, and then we're going to apply the product rule. So we're going to have k 9 times 5 times k to the 3 times 2, which will be equal to k to the 45 times k to the 6th power. Now, we have 2 bases. They have the same, we have the same bases raised to different powers. We're going to use the first rule, which is the power rule, the product rule, which states that we're going to keep the same base and then add the exponents together. So we have k to the 51st. Number 3, simplify each expression. So as you can see, for the first expression a, we have numbers. So 6 divided by 2, we know that is 3. So the answer is 3. And then we have a quotient. We're going to use the quotient rule, which says if you have the same bases, then you're going to keep the same base and take the power of the numerator minus the power of the denominator. Remember, if it's not written, it is 1. So this is going to turn into 3r to the 2nd power, or r squared. B, notice how we have a negative power here. It is your choice whether you want to turn it into a positive power and raise it, or you can use the quotient rule. If you use the quotient rule, remember there is a negative at the bottom, which means when you subtract and then negative, it's going to turn into an addition. So I'll do it both ways. So if I don't use if I don't turn the power in the denominator into positive, if I don't do that, this is how I will write it down. P squared does not have any other factors that combine with. And then I have q to the fifth in the numerator, q to the -3 in the denominator. It's going to turn into the same q and then 5 minus -3. So this is going to be p squared q to the 5 plus 3, which will be equal to p squared q to the 8th power. Now, if I turn it into a positive, this is what's going to happen. First, I bring that up with a positive power, so it's going to be p squared q to the 5th times q to the 3rd. Now, if we combine them together, p squared remains the same because I don't have any other factor with the base p. And q to the 5th times q to the 3rd, I will use the product rule. So this is going to be q to the 5th plus the 5 plus 3, which will turn into p squared q to the 8th. I don't know where the 8 went on this one. There. So you notice we have the same exact answer, and that's what you should have. Number 4, rewrite the expressions with a positive exponent and then simplify. So I have a negative exponent here, which means the denominator here is 1. So if I bring the whole expression down, it's going to turn into a positive exponent. So this is going to be, since there is nothing else in the numerator is going to become 1 over 2y to the 3rd power, all raised to the 2nd power. Now, if we want to simplify, we're going to use the power of a product rule and the power rule combined. So this is going to be 1 over 2 squared times y to the 3rd raised to the 2nd, which will turn eventually to 1 over 4y to the 6th power. The power of the power multiplies. Let me actually move this to the side. There. Now, b, I have a 5y to the -1. So the -1 is just affecting the y, it's not affecting the 5, which means the 5 is going to remain in the numerator. So again, the denominator here is 1. There is no point of bringing the 5 down because it doesn't have a negative power. So I will just bring the y down. The 5 remains up. So it's going to be 5 over y. And that is the simplest form. Then we have the 5th root of x cubed. Remember, we're going to turn this into an exponent. We're going to turn this into a positive exponent. And now it is not a positive exponent. Again, the index is going to be the denominator of the rational fraction, rational power. And the 3, which is the power of the radicand, is going to be the numerator. So it's going to be x raised to the power of 3 over 5. So that is how you're going to simplify it to a positive power. Number D, notice how this whole expression xyz is raised to the 0 power, which means the answer there is going to be 1. So the answer is 1 here. Another topic here, we're going to start add and subtract polynomial expressions. When we add and subtract polynomial expressions, we combine like terms. So we combine like terms. Like terms have the same variables, which is the base, raised to the same exponent. For example, 5x squared is the same as -2x squared. Notice how we do not care about the number, which is the coefficient. So the number in front of the expression or in front of the variable, these are called coefficients. We don't care about the coefficient. What we care about is the variable, which is the base, and the exponent. So in any expression, let's say you have the expression 3x to the fifth power. We call this number, we call it coefficient. And we call the variable the base, and we call the exponent or the power exponent. What we care about is the base and the exponents are the same. The coefficient doesn't matter. It tells you how many of these there are. So 3x to the fifth means we have 3x to the fifths added together. And when we add these expressions, we basically add the coefficients in front of them. It's like saying you have 3 apples if x to the fifth represents an apple. So let's apply that here. If you have 5 apples and then you take away 2 apples, if you combine these together, add them together, you're going to get 3 apples. So 5 minus 2 is 3. And then the 3 represents an apple, so that is x squared if x squared represents an apple. Unlike terms, they either have different bases or different exponents. So in this case, 4x and 3x squared both have the same base, however, the exponent is not the same, which means you cannot add them together. So if I apply the same example that I did before, 4x might represent 4 bananas. 3x squared might represent 3 apples. So you cannot add 4 bananas and 3 apples together. They're not the same type of fruit. So you cannot combine them together into one thing. For example, you cannot say you have 7 banana apples. It just doesn't make sense. So I hope you see what I'm saying there. When we subtract polynomials, remember to subtract every term. In other words, you have to distribute the negative inside of the expression before you combine the terms together. Okay? Here is a practice. Find the sum of the 2 given polynomial expressions. So we're adding here, which means we're going to just focus on like terms and add them. So I'm going to highlight like terms. So 5x squared is the same as 2x squared. And then I have 3x is similar to 2x. And then I have positive 2 is similar to negative 6. And then notice how this is an outlier. It doesn't have any similar terms. So now I will just add and combine like terms together. 5x plus 2x is 5x squared plus 2x squared is 7x squared. 3x plus 2x is positive 5x. 1 minus 6 is negative 5. And then you can say plus 5x cubed. I don't like it to be here. I like to arrange the terms by the highest power first. So what I'm going to do, I'm just going to remove it from here and I will write it at the beginning. It's positive, so I will say 5x squared. 7 is positive, so the sign of 7 is positive. And the positive at the beginning here, we usually do not write that. Okay. So that is the sum of the first 2 polynomial expressions. For the second one, notice how we have a 6 in front of the first polynomial expression, which means we're going to follow PEMDAS. PEMDAS means you're going to do the parentheses first. The parentheses are not, they don't have anything that we can simplify inside. They don't have like terms. And then you're going to do the exponents next. We don't have any exponents here to deal with. And then M stands for multiplication, so PEMDAS. So next you do multiplication division as you see them from left to right. So if you see multiplication first, you do multiplication first. If you see division first, you do division first. These are the same power. And then AS stands for addition subtraction. Again, addition and subtraction, these are the same strength operations. So you do them as you see them. So if you see addition first, you do addition first from left to right. If you see subtraction first, you do subtraction first. So here is how we're going to work this problem. First, we're going to do the multiplication. That is the first operation we see, which is 6 multiplied inside of the first parentheses. Remember, you're going to multiply 6 with every term inside. So 6 times 2x cubed, that is 12x cubed. 6 times 3x is positive 18x. 6 times negative 1 is negative 6. And then let's drop the parentheses from here. You have positive times negative is negative 8x. Positive times negative 2 is negative 2. So again, you distribute that inside or remove the parentheses, or distribute the parentheses, distribute the positive inside. Positive usually doesn't change the sign. That's why I ignored that here in the previous question. So now we're going to highlight like terms. So the first term does not have a similar term. We don't have any similar term to that. The second term has this term similar to it. Notice how I highlighted the sign before that, because the sign of that term is the sign in front of it. And then negative 6 is similar to negative 2. It's just a constant. So we have 12x cubed remains the same. Positive 18x minus 8x is positive 10x. Negative 6 minus negative 2 is negative 8. So that is the whole expression. I will do the last thing on page number 3, and then we will move on to a different concept. Find the difference of the two given polynomial expressions. So when you are subtraction polynomial expressions, the main idea here is to distribute the negative sign inside of the parentheses. If you don't do that, then you're going to end up having the wrong answer. So the first step is to distribute the negative inside. The negative basically changes the sign of the expression. In the other expression here, we have actually negative 2, so we have to distribute the negative 2 inside. We do multiplication PEMDAS. So let's begin with the first expression. We have 2y cubed plus 18y squared plus 7y minus times negative 5 is positive 5y squared. Negative times positive is negative 3y squared. Negative times negative y is positive y. Now let's highlight like terms. Negative 2y cubed does not have any like terms here, so we're going to keep it like that. 18y squared is similar to 5y squared, and negative y squared. I could have did the simplification here inside of the parentheses first. And then the last expression, 7y, is similar to positive y. Now we're going to add 2y cubed remains. 18y squared plus 5y squared minus 3y squared is positive 20y squared. And then positive 7y plus y is positive 8y. And we're going to leave it like that because we cannot add any of these terms together. Now, we're going to do the next one. 5y squared plus 3w squared plus 3. And then negative 2 times 4 is negative 8y. Negative 2 times positive 2 is negative 4y squared. Negative 2 times positive 1 is negative 2w. We're going to highlight like terms. 5y squared is similar to negative 4y squared. 3w squared does not have any like terms, and so is the rest. 3 doesn't have any like terms. Negative 8y doesn't have any like terms. Negative w, 2w doesn't have any like terms. Now we're going to combine. So again, 5y squared minus 4y squared is positive y squared. And then the rest of the expressions, or the rest of the variables, cannot combine with one another, so we're going to keep them as they are. So plus 3w squared, I just want to rearrange the terms. Let me actually bring the y next to the y. So minus 8y, and then plus 3w squared minus 2w plus 3. All I'm doing is just rearranging, so the w's are next to each other, the y's are next to each other, and the constant is at the very last. So that is how you're going to simplify that expression.